Okay. So questions you should be able to do on the final. You should make sure you can do something like this. And you should be able to do it without a calculator. Okay, approximate the area under the curve y equals 2x squared plus 3x plus 4 from x equals 2 to x equals 6. Use again equals 4 left endpoint and right endpoint rectangles. All right, that's enough there. We'll work on it together at this point. So you get points for this setting it up, and you get points for doing the calculation. Okay, so you get both. So I don't want you to get too excited about if you can't get the final number correct. So, well, let's draw a picture of what this looks like. We'll put it over here. It's some kind of upward parabola. The y-intercept is 4, and it goes up like that, and we're going from 2 to 6. Using rectangles. So those are our left rectangles. That's going to underestimate. These points are 3, 4, 5, 6. So the left endpoint rectangles will evaluate at f of 2, f of 3, f of 4, and f of 5. And the right endpoint rectangles will be at 3, 4, 5, and 6. And you're literally just going to plug them into the equation and multiply the width. And I'm very nice, I made the width of these rectangles 1. Now in the exam, maybe I'll make them 2/3 of pi or something equal, but probably not. I haven't done that so far. There's no reason I think I would now. So the width of each of these is 1. And you're going to want to do f of 2 plus f of 3 plus f of 4 plus f of 5. Which is 1 times, let's see, f of 2. So that's 2 times 2 squared plus 3 times 2 plus 4, which is, I believe, 18. 2 times 3 squared plus 3 times 3 plus 4 is 31. Correct me if I'm getting wrong. 2 times 4 squared plus 3 times 4 plus 4 is 48. And 2 times 5 squared plus 3 times 5 plus 4, I think, is 69. That comes out to 166. No? Yes, 166. How'd I do? Okay, so that's the area underneath estimate, and it's less than the total area under the curve. Feel free to check my arithmetic. Do it in my head while I'm talking, so I could be getting it wrong. So the right endpoint rectangles, you do the same thing, except we're going to use 3, 4, 5, and 6 instead of 2, 3, 4, and 5. So it's going to be 1 f of 3 plus f of 4 plus f of 5 plus f of 6. Nobody's spoken up, so I assume I have the numbers right. So 3, 4, and 5 we already calculated. That's 31 plus 48 plus 69. And let's see, 2 times 6 squared plus 3 times 6 plus 4 is 94. So basically we took away 18 and we added 94, so you're going to add 76 to the total. So that's 242. And that's the overestimate. So that's if you do these rectangles. So if I said, what's your estimate? Well, then you would just average those two numbers. Now, if we wanted to find the area exactly, we would have to evaluate this integral, which is from 2 to 6 of 2x squared plus 3x plus 4 dx. So if we average that, let's see, you get 204. I think that's right. 3408, yeah, 204. So the actual area is the integral of this, which is 2x cubed over 3 plus 3x squared over 2 plus 4x, evaluated from 2 to 6. Then you plug in 6, you plug in 2, and subtract. So let's see, that's 222 minus 16 thirds plus 6 is 34 thirds plus 8 is 58 thirds. So, which is 19 and a third. So you get 202 and 2/3. I think that's correct. It could be wrong. As I said, I'm just sort of making that stuff up. Okay? So we might ask you, find it with left, find it with right, find the actual value. We don't really care about the averaging. I mean, you guys have been able to average two numbers for a while now. Okay? So how do we do on this? Good? All right, let's have you do some more integration. Okay, there's 4 fun ones to start. Okay, let's go over these. How do you know when to use U substitution? Well, first, you try to do it without U substitution. So if you see a simple polynomial, you don't need U substitution for that integral. Or just plain old substitution. You don't need that. This is just 5x to the 4 over 4 minus 8x to the 3 over 3 plus 11x to the 2 over 2 plus 4x plus a constant. That's all you have to do. Okay, you don't need U substitution to do e to a power, as long as the power is just x. So that's e to the 2x over 2. Don't forget to divide by whatever's multiplied with the x. You don't do U substitution when you just have something over x, because that's just a simple log. And the square root of x is x to the 1/2. So the integral of that is x to the 3/2 over 3/2, which you could leave as over 3/2. You don't need to flip it and make it times 2/3. You can if you want. You should be able to do that if you have to use numbers. So if you have to do a definite integral, you have to plug in numbers at the end. Okay? So again, don't need U substitution for those. This one looks a little weird. You'd say, well, if I did use substitution, what would I substitute? Because the derivative of this is not this, or the other way around. But you could break this integral up into x cubed over x, 11x squared over x, plus 7 over x, And now it's a simple integral. So this is x cubed over 3 plus 11x squared over 2 plus 7 log x plus a constant. Remember I told you integrals are much more annoying than derivatives. Derivative. Yes?
It's supposed to be x cubed plus 11x squared. Right?
This should be x cubed over x is x squared. 11x squared over x is 11x.
Oh, okay.
Okay, and then 7 over x. So each of these individually is over x. Good? All right, the last one. First, I would rewrite this as x to the 3/10 minus x to the negative 3/10 dx. Then we integrate 3/10 plus 1 is 13/10. So it's x to the 13/10 over 13/10. And negative 3/10 plus 1 is 7/10. So x to the 7/10 over 7/10 plus a constant. Notice we didn't have to plug into any of these. Where would you see a definite integral other than just giving you one? We can give you a word problem that looks something like this. We could say something like, if marginal revenue, remember that's a derivative, the word marginal, you think derivative. Marginal revenue for manufacturer is R prime of X. X equals thousands of units sold. Find the total revenue for 10 units or 10,000. Suppose we give you something like that. Okay, you're a manufacturer. You do your marginal revenue equation. You figure out that it's negative x squared plus 18x plus 100. Find the total revenue for 10,000 units. So what you're going to do is you're going to integrate from 0 to 10 the marginal revenue equation. That's all you have to do. So when you see the word marginal, think derivative. When you see the word total, think integral. And a clue is this is r prime, and then you can go backwards and find r. Right? That would be r 10. Because 10,000, you plug in 10, not 10,000. So this is negative x cubed over 3 plus 9x squared, because it's 18x squared over 2, plus 100x. From 0 to 10. Again, it's 9x squared because it's 18x squared over 2. Then you plug in, and you get negative 1,000 over 3 plus 900 plus 1,000, which is 4,700 over 3, minus 0. Because when you plug in 0, these are all 0. and you know that's some number of dollars. Okay, I don't know what units we're making. Are we making refrigerators? Are we making, you know, something that costs a penny? I don't know. Just made the problem up. In the real world, of course, you care about these things. Okay, let's practice some other types of integrals. Go. Now I'll entertain you for a couple minutes. Okay, so these are all U substitutions. How do you know they're U substitutions? Well, first of all, otherwise you can't do them. Right? You look and you say, I can do x to the 4th on its own. I can't really do e to the 3x to the 5th plus 1 on its own, and since they're stuck together, it's got to be a U substitution, because we haven't done other techniques. There's lots of different types of integration, which we just don't cover. So I would let u equal 3x to the 5th plus 1, because that's the higher power term. Du would be 15x to the 4th dx. Then I look at my integrand, and I don't see 15x to the 4th, but I do see x to the 4th. So 1/15 du is x to the 4th dx. Now substitute, and you can rewrite this as e to the u, that's the 3x to the 5th plus 1, and the du would be 1/15 du. Now you integrate e to the u, and you get e to the u, plus a constant. So it's 1/15 e to the 3x to the 5th plus 1, plus a constant. Okay? How are we doing that one? Good? Okay. Let's try the second one. I look inside that cube root, and I see 1 minus x squared. I look outside, I see x, and the derivative of 1 minus x squared is something x. So my substitution will be, I'll let u equal 1 minus x squared, and then du will be minus 2x dx. And therefore, since I only have x dx, I'll do minus a half du equals x dx. Substitute. This becomes minus a half u to the 1/3 du. So we took that messy integral and we made a nice simple integral. Integrate u to the 1/3 and you get u to the 4/3 over 4/3. And then substitute back, and you can flip the fraction if you want. You get minus 3/8, 1 minus x squared to the 4/3 plus a constant. All right? Here, I have 3x squared plus 1 in the denominator, and I have x in the numerator. So the other way around, you do the division trick, which we did in the previous problem. But here, you can't really. So let's let u equal 3x squared plus 1. Du would be 6x dx. I only have x dx, so 1/6 du is x dx. So I could rewrite this as 1/6 integral of du over u. And you can't have u over du. You have to have du over u. You can't have a du in the denominator. It makes things really complicated. So this becomes 1/6 log of u plus a constant, which is 1/6 log of 3x squared plus 1 plus a constant. You don't actually need the absolute value bars on this one because 3x squared plus 1 is always positive. But if you left them in, that's okay. All right, last one. Now notice here, this is one of those annoying ones. X plus 3 and x are the same power. So you have to do sort of a little trick. You let u equal x plus 3, so du is dx, and u minus 3 equal to x. So you can rewrite this as u minus 3 times u to the 1/2 du. Remember, we did a few of these. Can I circle the answer? Sure. It's not really a circle, but it's the idea of a circle. So this becomes the integral of u to the 3/2 minus 3u to the 1/2 du. You get that by multiplying through by u to the 1/2. That is u to the 5/2 over 5/2 minus 3u to the 3/2 over 3/2. And then if you substitute back, it is 2/5 x plus 3 to the 5/2 minus 2x plus 3 to the 3/2 plus a constant. How do we do? Okay, so that's everything. Good luck on the final. We'll see you all Wednesday. I hope you enjoyed the class. And maybe I'll see some of you in a future course. Okay? Good luck.